Hi everyone, welcome once again to this podcast I Talk 1030, and today we continue to roll out immunology discussions to help improve understanding and comprehension of immunology outside there. And with me today is my co-host Joshua. Joshua, say hi.
Hi everyone, and welcome once again to more series and talks on immunology.
Thank you. So today will be our discussion will center around the innate and adaptive immunology. These are the very basic concepts of immunology and basically what the body requires to fight infections lie in between the innate and adaptive immune systems. And even as we roll out these discussions, uh, one of the triggers for an immune reaction is the recognition of pathogens. And if it is not pathogens, then it is the recognition of damage within our body cells. The innate system, as well as the adaptive system, must be conscious of the pathogens so that they can mount an effective immune reaction to these pathogens. And so, Joshua, in your reflection, we find the importance of the innate immunity, of the innate arm of the immune system in recognizing the pathogen and actually alerting the entire system.
Yeah.
How do you think this system really does this?
Well, I think the innate immune system is just as important as the adaptive system is. And other than the detection of a pathogen directly, it is triggered by cytokines and certain factors, either of the immune system or of the other innate mechanisms of biological, physiological mechanisms. And such include such measures as the complement system. For example, we know the complement system can be independent of the um, innate or adaptive system in terms of its initialization. But we are also aware of the fact that certain factors produced by injured cells, and this could be in the context of an acute inflammation, would trigger the first arrival of cells of the innate immune system, for example, neutrophils and macrophages. And there are also mechanisms through which the system identifies pathogens. So they will look for stereotypical patterns, and specifically, this would be the pathogen associated molecular patterns that are unique to non self molecules or
Yeah.
non self organisms or microorganisms. They are also aware and able to identify damage associated molecular patterns, which are molecules that are only exposed by self in the event of damage.
Yes.
So there are a lot of stimulating factors or triggering mechanisms to first arrival of innate cells in a site of infection or damage.
Mm. Yeah, awesome. And sometimes you and at the point of recognition of the pathogens, you've mentioned the pathogen associated molecular patterns, and you've
Yeah.
also mentioned the DMPs. And
Yes.
the body really needs to be clear on what is uh, not ours in this case.
Yeah.
Yeah,
Yeah.
because it must really know. For example, if you take in the case of microbes that have got a double-stranded DNA, you see,
Uh-huh.
even our bodies have double-stranded DNA, and the
Yes.
cells of the immune system, and especially the cells of the innate, because they are the triggers of this thing. They
Mm.
must be clear that which double-stranded DNA is ours here, and which
Mm.
double-stranded DNA is not ours. There must be a distinction.
Mm.
And from that distinction, they can now make a decision of whether to start triggering the immune system and connect back to the
Yeah.
adaptive
Yeah.
immune system. Would you
Mm.
would you would you make some comments on on the antigen presenting cells starting the game?
Yeah, of course, yeah, we are aware that the process of antigen processing and presentation, especially in the context of MHC class 2, is the link between the innate and adaptive immune system. And professional antigen presenting cells have been identified as either B cells, which are professional, or the monocyte macrophage systems, of which you could have the macrophages or the dendritic cells. And I think dendritic cells, your favorite cells, are
Yeah.
identified as professional antigen presenting cells. And this acts as a link between the
Yes.
innate and adaptive. But then
Yes.
again, we are aware that before these antigens are processed, they have to be internalized by process of
Exactly.
phagocytosis. And phagocytosis has to be mediated by some adapter molecules. So they could be these pattern recognition receptors, for example, that facilitate uptake. And some complement fragments also facilitate uptake by acting as opsonizing agents. So that after these fragments have been internalized in a whole, they are broken down, and certain portions of them are packed in MHC molecules and then presented now
Yes.
to T cells, T helper cells in this case, for purposes of activating now a more adaptive response.
Awesome. The events are actually quite mind blowing. If you can just imagine how the cells first of all receive the pathogens, break them down within the phagosomes, then
Yeah.
process them into chunks that can fit the MHC complex, and
Yeah.
then the MHC complexes arise.
Mm.
Uh, then the cell can now be able to present the patterns to cells of the adaptive system. It's
The
actually
adaptive.
a mind blowing process, because even if I imagine, because if you look at these APCs that you've mentioned,
Yes.
in most cases they lie low, like I would say like a roaring lion just lying there. Then
Yeah.
once they have met these pathogens, they feel
Yeah.
these are not our part. Then
Mm.
they start developing legs to walk to the adaptive immune system. They're kind of like
Yeah.
reporting. They receive the news, then start their journalism, report to the adaptive. Then the adaptive system knows what it does.
Yeah. Yeah.
Yeah, and
And there is also the tendency of um, professional antigen presenting cells not only working
yes,
with the antigens as veiled cells, but some also attract Th1 cells into a site of inflammation. So that if you look at the population of cells in an area where there's an acute inflammation and compared to an area where there's a chronic inflammation, you'll realize that there is population of T cells in a site of chronic inflammation, indicating that probably they have been attracted there by a
yeah,
profile of cytokines. So then there is that response happening at the lymph nodes
yes,
in the
yes.
T cell area, and then there's also T cells being activated and being mobilized or trafficked to a site of infection or inflammation.
Yeah, yeah, yeah. Now that we are almost connecting this part, now you see the cells of the adaptive immune system. Uh, they are waiting for the ball in their inner courts.
Yeah.
So, are they static where they are, or they keep on sampling to check whether the APCs have brought something new, brought something for me, then they leave?
Well, I think looking at it from a graphical perspective, it would be viewed as though they are waiting for them to be awakened or
Yeah.
unleashed by the dendritic cells. And it is that at that point that there's that wave of cytokine profile that comes with
Yes.
with antigen processing and presentation. We have interleukin 1, for example, I believe interleukin 6, 12, tumor necrosis factor, these kind of things. they activate, apart from the MHC and the CD4 molecules, activate T cells to proliferate. And then the T cells also produce interleukin 2, which not only acts on the antigen presenting cells but also has an autocrine function. And these cells begin to proliferate and increase in number. And in the process, they begin to mobilize and follow the trail of cytokines towards the site of infection.
Yeah. And so even before they receive these pathogens, I tend to think that they keep on moving from one lymph node to the other
Oh,
because
yes.
so that the APCs also look for them from one lymph node to the other. So whenever they
Yeah.
find themselves, they now meet and exchange. But I assure our listeners that the process of looking for each other is always so fast, and it nearly has no delay.
Yeah. And
So
it's
since
also, yes.
okay, since you can just carry on because I wanted to jump to the next session.
Oh,
But
yes.
just
I just wanted to briefly comment on the idea that T cells keep on moving or are trafficked from one lymph node to another.
yes,
We are aware that before they are activated or selected into clones, probably the population of T cells that are responsive to a particular antigen is low. So to increase their chances or to increase the chances of an effective immune response, it is safer to have them redistributed all over,
yeah,
so that in case an antigen is present in, say, on the foot,
yes.
and the clone that could have acted of it are probably somewhere in the axillary
So
lymph node.
it's too
It
far.
would take some time, yes. So to have them redistributed and you sort of give the police a transfer, move them from this station to another, that sort of also enhances the patrolling system.
Yeah, that's so wonderful. Now, since we've linked these arms of the immune systems, uh, nearly we've nearly said with some exceptions that the innate immune system begins the game, and there is what they can do, like mentioned the issue of the complement system.
Yeah.
Uh, but then there's what they cannot really do. So where do they strike the balance that we should now begin reporting exactly to the adaptive immune system? Where's the break point for these guys?
Well, I see their limitation to be what segregates them from the adaptive immune system. Because, Steve, we are calling them innate.
Yeah.
That that segregates them from what we would refer to as adaptive, because adaptive, as the name suggests, adapts. And it means that if there is an infection with a particular pathogen with a specific antigen,
Yes.
the innate immune system will identify it with a certain degree of intensity. When that infection has been contained, and unfortunately it recurs after some time, the innate system does not have an enhanced mechanism of dealing with it.
Yes.
The intensity does not change. And that is the exact opposite of what happens with the adaptive. It's much quicker, the response is quicker, and the means and mode of identification is even faster. We talk of clonal selection, clonal mutation, hypermutation, and such kind of things. It gives the adaptive immune system a better weapon to combat infections in the event that they recur. Again, here we are talking about specificity and memory, which the innate system lacks.
Yeah.
Yeah.
But then one day, there was a time I read a research paper that was proposing that the macrophages kind of have some memory in them. Though I don't know where the concept really came and disappeared. But
Yeah.
there were some views that macrophages kind of have memory in them. But then I still do not think that whether they have memory or not, I still don't. Okay, let's assume that they have. I don't think their memory will be long lasting as such. I think it's something that will be really short lived, and that is what really makes them uh, less preferable for heavy works that the adaptive immune system can really do.
Yeah, I mean, in terms of sustainability. But then
Yeah.
again, talking about their memories, we know that MHC molecules are considered to be of the immunoglobulin superfamily. because they have a tendency to identify antigens with some kind of specificity. And because these characteristics are determined at the genetic level, it could impart some level of specificity to professional antigen presenting cells. I don't know how much this would speak about their memory, because we do know that in the wake of a response to an infection, unless there are antibodies to enhance uptake,
Yes.
then macrophages will always act as they would in the wake of a primary infection. Perhaps more research is available to explain more of this, or yet to come. We do not know.
Yeah, possibly. So let's quickly jump to how now the innate system activates the adaptive system. We've mentioned that the innate system must take the information back to the adaptive, meet their compatible clones there, then the expansion begins. But how then does the activation takes place? Does it take place? Okay, initially you mentioned that some APCs attract the helper cells to within the sites. How does the activation takes place, and where does it even takes place in the first place?
Well, we are aware that once antigens have been processed, they are presented to T lymphocytes, and specifically T helper cells. And this has been mentioned because we know T helper cells are, well, they are called lymphocytes, meaning they reside in lymph nodes.
Yeah.
So the activation might be happening at the point where they reside. So it's probably at the T cell area of the lymph node, somewhere around where there is high endothelial venules concentrated to allow the extravasation of these antigen presenting cells to the T cells themselves. And apart from just presenting the antigens, they must also produce cytokines that act as activating molecules. And apart from just the MHC interacting with the TCR and the CD molecule, CD8 or CD4 in this case, there are also other co-stimulatory molecules, like the B7s interacting with the CD, is it 50, 50, 58? I'm not sure. But the co-stimulatory molecules, in their absence, would make it very impossible to activate T lymphocytes in the process of antigen presenting. In fact, it has been suggested that when co-stimulatory molecules are downregulated, the T cells are actually energized.
Exactly. Yeah,
Yeah.
exactly.
I don't know what you have to say on that.
You've provided a good overview of it, because for any cell of the innate immune system to activate an adaptive immune response, number one, it must rush to the lymph nodes, because that is where their targets reside. So
Yeah.
upon meeting their respective clones, there must be contact. The T cell must inspect, is this the right pattern
Yes.
for me to
Yes.
begin
Yes.
my activations? While still inspecting the patterns, there must be the co-stimulatory molecules, the CD molecules, to provide an extra energy, an extra support, actually, for these
Yeah.
for this reaction to take place. Now, uh, at the point of contact,
Yes.
there is a massive cell signaling that takes place. Cell signaling through the uh, MHC locus, moving all down to the nucleus of the T cell. Then now
Yeah.
we can have genes, the gene regulation and the gene expression starting to take place, so that the T cell can now begin to expand, and so that we can have more copies of the same clone.
Mm-hmm.
So once they're activated, there's always a risk of one thing, that things can go awkward. We've seen this in the case of let me give an example of COVID-19, for example, where we've seen a very heightened production of the cytokines, so that we
Yeah.
have cytokine storm. So, what's going to go wrong in this interaction between the innate and the adaptive?
Well, first of all, I think looking at it from the point where the antigen is being presented to a T cell, there is the tendency of the professional antigen presenting cell activating the T helper cell and at some point have a need to disengage. So if you remember the interaction between CD28 and CD80 and 86, one upregulates, the other one downregulates. So when a threshold has been attained, then there's a swap, so that instead of CD80 interacting with CD28 on the lymphocyte, it is now CD86 downregulating CD28, therefore stopping the internal cell signaling mechanism.
Okay.
I want to perceive a situation whereby this checkpoint system doesn't work. There will be an overstimulation of the lymphocyte and they will proliferate beyond a point that is desirable. Other than that, looking at even the antigen presenting cell itself, they have the internal receptors. For example, we have the caspase associated recruiting domain, nucleotide oligomerization domain in macrophages. And these molecules normally respond to antigens that are inside the cytoplasm of a cell, whether they are inside the phagosome or just floating within the cytoplasm. For example, ubiquitous antigens that are sequestered for presentation. These molecules normally stimulate these cells to start producing a cytokine storm. For example, in situation of Crohn's disease, you have macrophages that is constantly activated because the antigen inside the cytoplasm is not eliminated. So an individual may be responding to an antigen that was exposed to it a long time ago, but at the moment they still have professional antigen presenting cells that are producing cytokines, and these ones normally result to undesirable inflammatory responses. So again, we could be talking about immune dysregulations where cell activation is happening and there is no fail-safe mechanism to stop it.
Yeah.
Yeah.
So you've given a good overview of a case where the system can go off. Yeah, and I will provide an input in the case of cancer where actually the system is down. So that while the adaptive and the innate meet, now the innate makes a mistake of not providing the co-stimulatory molecules. Either they're down regulated by the cancer or the other systems. So once these molecules are not there, the pertinent thing that can go wrong here is that the adaptive might fail to be activated, and that leads to a non-response, and that leads to exacerbated disease. So let's quickly jump and summarize with the checks and balances in these systems, because while we've noted that something can go wrong, there must be checks and balances. The body must know that now the infection has ended. Our adaptive arm has done its job, has kept the records. The innate system should cool down. We should not be having a reaction. How does these two systems do this?
Well, I think from where I sit, I look at it in terms of the Th1 and Th2 pathway, because these are the recipients of antigens, either from macrophages or dendritic cells or B cells. So B cells, for example, represent the antigens to T helper 2 lymphocytes. while dendritic cells will always present them to Th1 cells. Now, the cytokine profile that these pairs of interactions elicit normally downregulates the other. So this becomes, in a way, a checkpoint mechanism that prevents the other pathway from exceeding its expectations or going beyond what is required of it. The other mechanism is, again, when adaptive arm has been activated and it has cleared or facilitated the clearance of an antigen, first of all, we recognize that the first thing that elicits an immune response is the presence of non-self. If the non-self has been eradicated, there is no mechanism, again, to elicit more immune response. Now, the system now begins to calm down. And of course, there are other regulatory mechanisms, things like interleukin-10. There is things secreted by the Tregs also play a role. Because again, as Th1 lymphocytes or Th2 lymphocytes or cytotoxic T lymphocytes are receiving signals from antigen-presenting cells for them to respond, Tregs are also receiving the same antigens and they are being activated, only that the cytokine profile downregulates an immune response. So it also puts a balance on itself so that once there's no need for the system to be hyped, then the Treg system sort of becomes a bit hyped because their response is a bit more delayed. And this is very convenient because it gives time for the immune system to do its work and then now relies on the regulatory mechanisms to calm it down.
Oh, yeah, awesome. That's a very high level summary. And I would not really want to delve into the adaptive because you've really explained it with the Tregs and all that. I will provide additional insight in the negative feedback loops for the innate immune system. You've highlighted the interleukin 10. That is really important. I will also add of molecules produced by the mononuclear phagocytes. So the mononuclear phagocytes produce some antagonists that actually block interleukin 1. You remember interleukin 10 also block interleukin 1 and also 2.
Yes.
They are antagonists produced by mononuclear phagocytes that actually block interleukin 1 and therefore inhibit or begin to downregulate, first of all, the activities of the innate and then the activities of the adaptive. And the other mechanism that I would really think of is the signaling pathways. I seem to be biased towards these pathways because there is a signaling pathway called the JAK-STAT signaling pathway. And the JAK-STATs are actually very important even as the adaptive and the innate system communicate. In most cases, they must just be activated. Now, one thing that blocks the JAK-STAT is the activation or the production of a different set of proteins that are called the SOCs. This is just an abbreviation for the suppressors of cytokine signaling. So once these proteins are produced, then they begin to inhibit the JAK-STAT pathway. Then we begin to see the immune reaction, especially in the innate arm, begin to subside. And when the signal and the pathways of the innate begin to subside, then we can at least be sure with augmented activities of the Tregs and the decline in the interleukins that the adaptive system will also begin to behave.
Okay, it's interesting.
Yeah, so give your final shots.
Well, I consider the innate system to be peaking in terms of research, at least as far as I can reckon, because there's been a lot of focus on the adaptive system. And yes, we must admit that
exactly
a lot of good work has come out of it. We have benefited a lot from results of research in the adaptive immune system. And it's about time the innate also be considered, because there are a lot of conditions that are logical purely because of an over-responsive innate system. And the therapeutic interventions that are available are becoming better and better, so long as the system is being investigated and understood more. We didn't have a lot of time to comment on chemokines and cell addition molecules, and basically the molecules that are responsible for cellular migration and feeding into a site of an infection. But I reckon that current therapeutic interventions that are available have risen as a result to a better understanding of the chemokine profiles that are present in inflammations in areas where we do not want an inflammation to happen. For example, in the brain, we have conditions like multiple sclerosis. So to curb them, we may have to understand how the innate immune system works, because those are chemokine-mediated inflammations. So the innate immune system is important and very interesting, and cannot be segregated or compartmentalized from the adaptive. They work hand in hand. Though there are mechanisms that are restricted to the innate system, there's a lot of correlation between the innate and the adaptive affairs we have discussed in this discourse.
Yeah, and I would really add that research is currently being expedited to see how their innate arm can be used to increase the activation of the adaptive arm. So the target is to use the innate system. The target is to use the innate system to produce a good effect in the adaptive arm, just like using the innate system as a vehicle to pass some message to the adaptive system, so that its activation can be expedited, so that it can provide the most reasonable reaction to either cancer or infection. I hope this research will provide good solutions to humanity, and so I think we'll call the podcast to a halt as we keep on to wait for other podcasts. I would say thank you to all our listeners, and see you in the next session.
Thank you, everyone, and have a good listening. Enjoy.
Okay.